Hello everyone, today we are going to solve two examples using a technique called implicit differentiation, so let's go. Find dy over dx if 4x squared plus x plus y cubed plus 9y equals 0. To solve it, we differentiate both sides with respect to x, and when differentiating y terms with respect to x, treat y as a function of x and apply the chain rule by multiplying by dy over dx, so it will be 8x plus 1 plus 3y squared dy over dx plus 9 dy over dx equals 0. Next step is to take the terms that contains dy over dx to one side and the rest to the other side. So 3y squared dy over dx plus 9y dy over dx equal minus 8x minus 1. And the final result will be dy over dx equal minus 8x minus 1. Over 3 into y squared plus 3. Now let's solve this example. Find dy over dx if x cubed be plus 3x squared y squared minus 9xy plus y squared equals 0. In this example, it's a bit different. We have a product of x and y, and to solve it, we differentiate first time with respect to x, and the second time we apply the chain rule. So it will be 3x squared y. Now the second time we leave the x cubed as it is and we differentiate y, then we multiply it by dy over dx plus 3 into 2xy squared plus 2y dy over dx x squared minus 9 into y plus x dy over dx plus 2y dy over dx equals 0. Now we solve it like the first example, so it will be x cubed plus 6yx squared minus 9x plus 2y dy over dx equal minus 3x squared y minus 6xy squared plus 9y. And the answer will be minus 3x squared y minus 6xy squared plus 9y over x cubed plus 6yx squared minus 9x plus 2y. If you enjoyed this video, don't forget to like and subscribe for more.